Okay, the end of 6.2 is this last example, and a Riemann sum is in simplified form should be unsimplified before being translated into a definite integral. So for example, they took this one that was k to the third over n to the fourth, and they said, okay, well, I know that 1 over n had to be my delta x, and so if I pulled that out, that would leave me with k over n to the third. That k over n tells me that it's not plus or minus anything. That tells me that my a is 0 because this is my x sub k. And remember, that's a plus delta xk times k. So you can see that your a is 0 there. And so you can see that that's going to be x to the third power, right, as your function. So that's going to be your f of x. And since your delta x is 1 over n, that must have been b minus 0 over n. So b had to have been 1. Okay, so your a is 0, your b is 1, and your function is x to the third. That's why it was the integral from 0 to 1 of x to the third dx. So let's look at number 1. So if you were going to, think about what this was telling us, k equals 1 to n, that's the same for everyone. Let's think about k over n cubed to the 1/2 and what we could write that as. That could be the same thing as k over n to the 1/2 times 1 over n squared to the 1/2. Do you see why I took that n squared? Because I know I want this to simplify to 1 over n. So 1 over n is my delta x. So my b minus a is 1. And then square root of k over n, my x sub k is k over n. So my x sub k is just k over n. I know my a is 0. And if my numerator of my delta x is 1, then my b is 1. And so I've got the integral from 0 to 1. And then if my x sub k is k to the n and I got it as square root, this must be square root of x dx. So this would be your integral. And if you put that into your calculator, you should get 2/3 as your value. Okay, so for the next one, we are going to focus on that nth term. So I'm going to focus on, what that nth term is. And I'm thinking that you have here your a is 0, your b minus a is going to be 1, so your b is 1, because this to me looks like k over n squared times 1 over n, because that would give you n squared, and then times n would give you n cubed in the denominator. And since it's like 1 squared, 2 squared, 3 squared, so it's your k is being squared. So that's why I knew it was k over n squared. So, so this is what your x sub k is. And your delta x is 1 over n. So we've got this being equivalent to the integral from 0 to 1. Of x squared dx. And that one would give you 1/3 if you put it in your calculator. Math 9, remember. And part C. So this one actually has your x sub k to be 1 plus 16k over n. And so I can already see my 8 over n as my delta x. So my little a is 1, and then since my b minus a is 8, so b minus 1 is 8, my b would be 9. And this is going to be your function. If you factored out, so if I put, I don't even know where to write this. I'm so sorry. If I put this as, and now my pen won't work, 2 times 1 plus 8k over n. So this is like my x sub k. Is 2 plus 16k over n minus 1. And then that's how you would get your, that's how you got your 1 plus 16k over n. This one was a little bit tricky because when you took your 8n here, you were left with a 2. So remember how we said our x sub k was equal to a plus delta x times k. Well, I quickly saw that there was an extra 2 there. And so that should have been your hint that, okay, wait a minute, let's think about this as that 2 being factored out. And that's how they got the 1 plus 16k over n. So you have to be careful on that one, but that just tells you that your function is your ln. So you've got your integral from 1 to 9, ln of 2x minus 1 dx. Because this was, you've got your 2x and then minus 1. So this was your, this ended up being your 2x, right, after we distributed, and then minus 1 simplified to 1 plus 16k over n. And we knew that, again, because our delta x was 8 over n, and this was not just 8k over n. If it would have just been 8k over n, we could have quit. But we couldn't do that. We had to figure out, we had to dig a little bit deeper because it wasn't just 8n there, 8 over n there. So now if I take this and put it in my calculator, I'm going to get 16.0823. So I had my integral from 1 to 9, and then it was equal to 16.0823. And just to reiterate that last example again, just to go through it again, when you are thinking of what your function was, because it was ln of something, and you decided that, okay, my delta x was 8 over n, my x sub k was 1 plus 8k over n, and so I'm going to put my delta x, or my x sub k, into the x of my function. And we just want to make sure that that worked, because that's what our thought process was. So this gave us 2 plus 16k over n minus 1, and that would give us 1 plus 16k over n. And that should have been what we had right here, ln of 1 plus 16k over n. So, you know, this is our function. So that's our f of x function. So when we, you know, take the limit of the summation, it was our, you know, f of x sub k times delta x.